Shell's Malampaya offshore natural gas platform and onshore plant comprises over 19,000 IO. The operation fuels 3 power stations with 3 gigawatt capacity to provide light and energy for Luzon, the largest of the Philippine islands. In designing the platform and onshore plant, which went online in 2001, Shell needed exceedingly reliable process availability to provide continuous delivery to the power plants, which supply 30% of the country's power.
The actual project spec for the gas plant availability is high, 98+%, in the respect to we have to continually deliver gas to our customers. In this case, we have a system where if you have a problem, you only have 10 minutes to do something about that. If you lose your gas supply, it effectively means you can black out the whole of the Luzon island.
To reduce helicopter travel, offshore living, and platform footprint, Shell wanted to reduce the platform's manned operation time.
The design intent is that the platform will be unmanned at night and will have minimum manning during the daytime in the control center. To enable that, we had to have an extended network over to the OGP via the satellite link. It's a virtual continuous LAN.
To meet this mission-critical process and rigorous performance specifications, Shell looked to the Delta V digital automation system as part of the plant web digital architecture from Emerson Process Management.
The main reason for selecting Delta V together with Foundation Fieldbus was to meet the high availability of the Malampaya project.
We have over 1,500 Foundation Fieldbus field devices.
I think one of the reasons that Malampaya chose to field bus technology was the cost implications. Obviously there were savings to be made on cabling, on commissioning time, and the availability was also a factor, as well as the low manning philosophy for the platform.
The automation system allowed Shell to ensure intrinsic safety standards to meet availability needs, and the field bus technology let the company save on installation costs.
On the platform, we decided to go for intrinsic safety in the field devices very early on in the project. In looking at the system components, we identified that it was necessary to have a redundant H1 card, especially on the OGP, where we have no capacity in the system if we have a failure on the OGP.
Our colleagues offshore have been in the situation where the actual PC system's gone down, but in the background the field bus technology is still controlling the process, and that's a huge benefit. On other systems that doesn't necessarily happen, and it can cause plant upsets.
I definitely feel that the Foundation field bus is the way forward, that's for sure. I mean, the costs saved, for instance, are really significant.
Where we do benefit is on the number of home run cables and the size of the home run cables. That is, there is a saving there to be made.
With the digital systems installation, the benefits became apparent.
The small footprint of the Delta V system was certainly a benefit on the platform where we're space constrained.
Commissioning of the platform was on time with regard to meeting the gas delivery date.
From the perspective of downloading to the devices, commissioning the segments, that went very well. No problem at all, and probably the average time to commission a device was about 20 minutes.
The training of operations engineers was a big consideration, because what we were trying to do was take Filipino nationals and train them up in a high-tech industry. They've taken it to it like ducks to water, so that they've had quite a bit of an involvement in that.
Working with the Delta V system in terms of engineering and documentation has been very good in terms of configuration. It's very easy to configure for the engineers on my side in KBR to put together a typical logic diagram, and for the configuration engineers to take that, transpose that logic diagram straight away into the Delta V format. The biggest single improvement is the fact that it's self-documenting. It's all online help. You don't have to go searching through very detailed manuals in order to build a particular set of configuration.
Compared to other systems, I guess its main advantage is its flexibility and the way that you can network the operating stations, the servers and so on.
I would say that one of the advantages is the scalability of the system.
Scalable is important because for future applications we should be able to have almost online getting things added to the system. And we cannot predict at this moment in time what kind of changes that or application that will be. So it is very, very handy for us to be able to scale it up.
The digital automation system, field bus technology, and smart field devices comprising the plant web architecture provide operators with enriched plant information, all integrated into a single system.
PlantWeb basically gave us the basis to extend out into the package units to all the third-party suppliers and to provide a totally integrated system which we hoped would provide us with the availability we required, but more importantly also to give us the single window into all the processes.
The embedded diagnostics in the digital system allows Shell to contain maintenance and manpower costs while meeting its availability needs.
It's mainly the feature of AMS which will enable us to do this remote diagnostics. And yeah, that's the only way with low manning to give a very early indication if there is something wrong. If you don't need to send operators to the field again and again to check the instrumentation.
The AMS, which is designed into Delta V, we're basically looking at that to provide remote diagnostics. In order to achieve that, we have to get the information from the field, which is why we went for Foundation Field Bus.
The system's embedded historian lets Shell keep tighter control of its operations and to delegate maintenance to its suppliers.
Both the platform and the onshore gas plant have their own historians, and there's also a central historian which is based on the onshore gas plant. We store a large amount of information on the historian, and that's used for trending. We also access that information on a web server.
Certainly that's a big benefit, is the trending of information, to go back after an event to see how it reacted, what improvements we can make, and it gives us a good history, to be honest.
Yeah, very useful, the trending, especially if you're monitoring a critical parameter.
The digital system's use of the OPC communications protocol lets Shell seamlessly integrate disparate systems and equipment.
By using OPC, we had a common form of communication between the Delta V platform and the third-party equipment, but it also made all the information from the third-party equipment available to everybody. So basically at the moment, if the vendor of a compressor wants some information on his own package, needs to know some process information, some safeguarding information, all that is available to him via OPC.
I think the use of OPC, again another first for the Malampaya project, is definitely the way to go. Much more faster and efficient to use than, say, Modbus. It definitely has advantages, and there's a lot of things you can do with it over and above, say, the traditional Modbus approach.
And with the system's remote diagnostics and control features, Malampaya project stakeholders can monitor the process anytime, any place.
During the commissioning phase, we had a link with Austin to get via PC Anywhere access to the system, and that helped a lot for troubleshooting.
The benefit of remote monitoring obviously is cost for one thing, because we have the experts not on the platform but in their own office environment, being able to have a look at the information as it comes in, have the time to sit down and analyse it and give us feedback.
So it's also been useful in so much that because of the remote access capabilities, despite the fact that these people don't even have representatives on the platform, it's been tied into their maintenance contract, so the suppliers are responsible for the condition of their own equipment.
For a project of this magnitude, built on new technologies, Shell needed local support it could count on for its automation system.
Working with Emerson personnel, their engineers and project managers was excellent.
Local support for the system that was selected was important and an important consideration. Having Trigon in the Philippines has been extremely useful. Knowing that there's a solid backup to a local supplier is also very reassuring.
And with the system's success, Shell looks for future implementation opportunities.
The investment in the Foundation Field Bus and the plant web equipment was a considerable learning curve for us. Up to now, it's demonstrated that we took the right choice. And certainly within Shell, I think we'll be taking this route again. I know that in PDO, they're using Foundation Field Bus, and certainly I think in SPDC in Nigeria, they're also looking at using the same system.
I would say, based on previous projects I've been involved in, the success rates with this control system is probably the best I've seen so far.
There's no reason why the plant shouldn't operate with very high reliability as it stands at the moment. And certainly I don't foresee any system problems which would cause an outage.
I am confident the system will provide that high availability figure.